Hello and welcome to this session on master alarm databases. My name is Mick Brown. I'm one of the senior safety engineers at Exida. My background is in control systems for nuclear power stations, where we started organising and rationalising alarms in the early to mid-90s, and that was at a time when the international standards for alarm management were in their infancy. So here's our agenda for this session. We'll talk about creating a master alarm database, what it is and what it's for, how you go about creating one, what information should be in it. We'll be documenting the results of rationalization in the master alarm database. We'll be creating alarm response procedures. We'll be talking about integrating the information from the master alarm database into our management of change process. We'll be updating the control system alarm configuration, and we'll talk about best practices and other considerations. There are two standards which are relevant to alarm rationalization, and they are ANSI 18.2, which is updated in 2016, and IEC 62682 version came out last year in 2022. And both of those standards incorporate the guidelines that are in EEMUA 191. Both of those standards define a master alarm database as an authorized list of rationalized alarms and associated attributes. And we will be discussing rationalization soon. Now, a lot of people call the master alarm database by other names, such as an alarm table, an alarm response manual, or a variable table. But one of the advantages of a standard is that it establishes an agreed set of references and names which everybody understands, and in doing so avoids ambiguity. Now, there's no requirements for the format of a master alarm database. It can be any usable form you choose, but it should be one that is compatible with your control system, such as a .text file, a .csv file, or a spreadsheet. But it should be in a form that can be used by any tool that you may want to use for alarm rationalization, such as SIL alarm. So the master alarm database is where we want to record information about alarms. But what do we mean by an alarm? Well, ISA 18.2 and EEMUA 191 are clear on what constitutes a valid alarm. An alarm is an audible and/or visual means of indicating to the operator an equipment malfunction, a process deviation, or other abnormal condition that requires a timely response. And that's important. Also remember that the operator is the intended audience for alarms, and what we put in front of him should only be events that are in fact genuine alarms. There are many alarm systems that contain information about events that do not require any operator action or are about expected events. The idea of rationalization is to put these events into separate lists away from the genuine alarms, allowing the operator to concentrate on what he really needs to attend to. The first step to constructing a master alarm database is understanding what our philosophy will be towards alarms. And we do that by constructing another document called the Alarm Philosophy Document. This document establishes the standards for how your company or your site will address all aspects of alarm management, including design, operations, and maintenance. It should contain the rules for classifying and prioritizing alarms, for using color to indicate an alarm in the HMI, and for managing changes to the configuration. It should also establish key performance benchmarks, such as the acceptable alarm load for the operator. That's the average number of alarms per hour. For new plants, the alarm philosophy should be fully defined and approved before commissioning. So this document is the starting point and will lead on to creating the master alarm database. But why would you create an alarm philosophy document or an APD? An alarm philosophy document is the bedrock of rationalization. If you get this right, then you're likely to make a good start with the master alarm database. It's critical to creating and maintaining effective alarm systems. It creates a common understanding for everybody It establishes how you do things and will do them consistently. It outlines the methods of solving alarm management issues, and it's required by ISA 182. And in the event of an audit, you can demonstrate compliance. It also provides an opportunity to create a more effective alarm management program, and that equals operational excellence. So we're on to the first step of rationalization, and the goal here is to create the optimum set of alarms needed to control the process and keep the plant safe. Now we do that by looking at our existing databases, and we review and analyze them to make sure that they meet the requirements of being an alarm. Does it indicate an abnormal condition? Does it need an operator action? Is it unique? Or are there other alarms that indicate the same condition? Does it require a timely response? So once we've defined that it is an alarm, we can then look at the alarm attributes, its priority, its classification, and we can document all that. We can document the cause, the corrective action, the consequence, and we record them all in our master alarm database. We can also check our other input documents to see if we've missed anything. So we can look at our HAZOPs and LOPers to see if we need to add any alarms, because alarm rationalization isn't about getting rid of alarms necessarily. It could be that you need to add alarms. So we're talking about the optimum number of alarms. We've also got to carefully go through the PNIDs and the complete IO lists or databases to check that we haven't missed anything. And by cross-checking these documents, we're very likely to catch the need for alarms that have been missed, or identify those alarms currently configured that don't, in fact, need to be alarms. Okay, so now we've decided that we have an alarm, we're going to use our master alarm database to record what the attributes of that alarm are. So what do we mean by an attribute? Well, it could be the settings for the alarm within the process control system, such things as the alarm set point, the alarm priority, or any off or on delays. Now here's what should be in the list of attributes for an alarm, and this is what is required by the standards. Both standards are very similar, though there is an added extra requirement for IEC 62682, which was added in the recent update, and that is to do with the likely cause of the alarm. So on the left, that's a list of what is required, and you need the tag name, the tag description, and things like that. Incidentally, a tag number should also have an alarm name associated with it, and it's important to distinguish between the two. A tag can have several alarms associated with it, as in tag name TI1001. That could have a high alarm which will be called TI1001_high, or a high alarm, so TI1001_high, and so on. On the right are recommended items, but I would say EU and engineering range are very, very useful, especially when assigning set points and hence response time. SIL alarm can work out where the set point on an analog alarm should be based on this information. Sometimes the operators just know, or the operating manuals will tell you, or the APD will tell you where the set point needs to be, but it is a cross-check as to whether you are allowing the operators enough time to respond, because SIL alarm can actually work that out. Other entries will be very useful when filtering and sorting alarms into groups, so they're not required, they are great to have. Now there's some other information you may want to include. You can have a master alarm database to do with normal operating envelope of the plant and how your alarms to relate to that. Now SIL alarm will function without them, but this information can be useful when deciding whether to add or delete alarms, and trip points are a good example. You may want a high alarm well before you trip, but you may want to also know that you've actually tripped. If there's no action for the operator, the consequence has happened after all, that could be considered an alert, so not an alarm. But if the operator needs to reset the plant and get it back online in a timely fashion to avoid excessive financial losses, then that could be considered an alarm, because he has to carry out a response. So that means that you would want to add an alarm, and this is useful information in deciding that. Now, these deviations from the norm and their extent can be very useful in other additions to the master alarm database. Now, in a little bit more detail, for each alarm you may want to record the normal operating levels of the process, also the threshold where a consequence will occur, and that in turn will help you to determine those set points for the alarm that should be set so you can avoid that consequence. There are also user-defined fields available for you to note any information which you feel is important and that you would like to record in the master alarm database. And there are 12 such fields available in Exida's Cell Alarm tool. You can also configure the tool to display that information where it is relevant. So here, our user-defined fields are being displayed in the set point determination page. So now that we know what an alarm is and what we want to record about an alarm and enter it into the master alarm database, we need to think about recording where the alarm has come from. Now, there are many different sources for identifying potential alarms, including operating procedure reviews, process hazard analysis like PHAs or HAZOPs, and LOPAs, accident investigations, P&IDs, a very important resource when carrying out rationalization, or quality reviews. Now, it can be important to record the source of an alarm configuration. If it came from a HAZOP, for instance, and the alarm is considered a safeguard, then the alarm will be considered a safety alarm, and we will need to include that as a highly managed alarm requiring special attention. So when we're creating a master alarm database, we would usually export alarms from a DCS system. So this is a brownfield site where we've got an existing list of alarms, and we need to rationalize that list and compare the alarms against the criteria and whether we're going to keep it or get rid of it. Now, if you're on a greenfield site, of course, there is no export from the DCS. There is no alarm list as yet. So we need to use all the other input documents like HAZOPs and LOFAs and the operational procedures to create a main alarm database. So now we have a master alarm database. We have a list of alarms in it, and we're going to rationalize each of the alarms. And we do that by asking ourselves the following questions. Is it a valid alarm? Is this alarm telling us about something that the operator needs to respond to in a timely fashion? What's the consequence of ignoring this alarm? What's caused the alarm? And can we confirm that process abnormality in some other way? And what do we have to do to correct the abnormality and bring the process back to normal? That's the first step in rationalization. So the next step in rationalization is to decide on the priority of the alarm. The reason for doing that is if we have a whole list of alarms, we need to know which ones are more urgent and which ones we need to deal with first. And that's the point of setting a priority. Now, we set the priority based on the consequences of inaction. So if we don't respond to the alarm, what will happen? And how long have we got to respond? So a combination of those two matrices will help us to decide what the priority of the alarm is. So here we are on the Still Alarm tool prioritization page, where we're going to use pull down menus to fix whereabouts on the matrix we think that this alarm should be. And the matrix will work out what the priority of the alarm should be. We can compare it with what was imported and decide if we're going to leave it as it was, use the matrix, or we can just override it and make our own decisions based on our expertise and the rationalization team's decision. So the next step in rationalization is to classify an alarm, and that's actually a requirement to classify all alarms. And what you have to do here is to group the alarms that might need special attention. For instance, you've got personal safety or protection alarms, so they will need to be tested every week. Like fire alarms, I know that we used to test weekly fire alarms in power stations. So also there's things like gas monitors and stuff like that. And there might be environmental protection, so they have a particular procedure attached to them for environmental protection alarms, and they might need to be treated differently. Highly managed alarms belong to a class with more requirements than other general alarms. So you need to group these alarms in and classify them and treat the alarms appropriately. So here we are on the classification page of SIL alarm, and it should be noted that alarms can belong to more than one class, and that can be recorded in the master alarm database. We also have a safety tab in the tool which can be used to record whether this alarm was installed as the result of a HAZOP or a LOPA, as we've discussed before, and whether it should be considered as an independent protection layer or a safeguard. Now this can be important, as we've said, to identify and record this, because it could make the alarm part of a group of highly managed alarms which need special attention. And the next step in the rationalization would be setting the set point for analog alarms. And we have got in the tool ways of doing this. So if you enter in what your high and your low engineering units are, where the consequence thresholds are, you can also put in what the rate of the change of the process is. So it can work out for you how long you've got to respond to this. So you can use this to cross-check that the set point is in the right place. And 9 times out of 10 in a rationalization process, operators will tell you where the set point should be based on the operating procedures and also their experience. So they'll tell you whether these set points are in the right place or not, and they should comply with the process. But the tool has the ability to work out or cross-check that your set point is correct. Now in SIL alarm we have the ability to set conditional alarming, for instance using dead bands to eliminate chattering alarms and things like that. Now it's my view that we should carry out this sort of conditional alarming down at the PLC level, not up in the alarming area in the SCADA, and I'll explain why that is later on. Advanced alarming is recommended by the standard. It's not required by them, but it is recommended that you use advanced alarming to enhance the performance of your alarm system, such as manual suppression. And this is where an alarm is manually depressed by an operator to take the alarm off the alarm list, for instance if it's a nuisance alarm or if you're undergoing maintenance and the alarm shouldn't sound while that maintenance is going on. You can use advanced alarm designs to carry out suppression automatically. So you can suppress an alarm automatically based on either the global condition of the plant, you're operating in a different mode, or it could be to do with the plant the alarm relates to. For instance, a pump that is no longer running because it's racked out or isolated, you wouldn't need a low flow alarm from that pump, so you could suppress that alarm based on the pump condition. You can use state-based alarming, or that modifies an alarm attribute such as a set point, and that's based on a defined operating state for equipments or processes. In this example, the alarm's actually suppressed, and that's based on the condition of another piece of plant. And in this example, the alarm attributes have been changed by dynamic alarming, so the priority of the alarm has been downgraded from critical to warning because the plant is in a startup state. So another advanced alarming technique is flood suppression, and this is where an event produces a plethora of alarms that you don't really need. What you really want to know is just have a single alarm that tells you that the event has occurred, and what you can do then is use that alarm to suppress all the other alarms associated with the event. Now, the master alarm database can be used to store alarm response procedures. These alarm response procedures, are sometimes called AORAs or action on receipt of alarms, are a requirement in the standards. They show an operator how they should respond to an alarm. The standard doesn't dictate how you should present that information, but they do say what information should be presented to the operator. And if you look, you'll notice that the information required by this section of the standards is exactly the same as that for rationalization. You need to know what happened, what should I do, how long have I got to make this decision and carry out the action, and what will happen if I don't respond. So here we are, here's that list from the standards. It tells you exactly what should be presented to the operator in the action on receipt of alarms or the response procedures. And you'll note that the list is identical to that which is required for rationalization. So we've already got that information and it's easy to recall and present to the operator. That can be in the form of written procedures that have been printed out from SIL alarm, or faceplate information, or the use of the SCADA help screens. So I'm going to talk about the master alarm database key features that are so useful when rationalizing alarms, particularly in the way that the tools like SIL alarm can record the alarms and their attributes in the master alarm database. We can use SIL alarm to take that information stored in the master alarm database and put it into the alarm servers within the DCS. We can use the filter tool to focus on a particular group of alarms like diagnostics, or all the digital alarms, or all alarms from a particular part of the system. I'll talk about the different reports we can produce and how we can copy the attributes from a single alarm to other similar alarms, and in doing that we can rationalize alarms in bulk. I'll talk about how we can use the master alarm database to assist in our management of change procedures and how we can audit the differences between the master alarm database and the alarm servers in our DCS. Now, having used SIL alarm to record the results of the rationalization exercise, we can use that information to make the necessary changes in the control system. When the changes are to be made to the alarm server level of the system, such as changes to the alarm priority, alarm limits, changes to the engineering units and the range, suppression timeout, and the alarm help guidance for the operators, we can import those changes directly from SIL alarm outputs in the form of text files or .csv files. And now, whether changes are made at the logic control or a PLC level, changes to the logic for dynamic alarming, we can also use these output files to generate reports that contain the necessary modification information so we can direct and record those logic changes. And here's an example of that where we've got a written output from SIL alarm. We can use that to actually direct the logic changes here in the DCS level. And that can become part of your management of change procedures where the information is actually recorded and kept and controlled and can show what changes you've made to the system to facilitate the rationalization of alarms. Where a main alarm database becomes quite large, it's useful to be able to filter the alarms into temporary groups. This filtering is quite powerful and enables you to effectively group alarms in a relatively sophisticated manner. And that enables you to rationalize just one alarm, and then you can rationalize the whole group by copying the attributes of that one alarm to all the others. You can do that by enabling the filter on the dedicated screens to include all alarms from a particular plant area, or alarms that are drawn on a particular P&ID, which is especially useful. Or you could show, for instance, only safety-related alarms. As you can see from this example, filtering can be defined in quite clever ways to display groups with very specific kinds of relationships. An added advantage is you can save these filters and recall them later. So here's an example where we are copying the attributes for one alarm, which is in the bottom right-hand box, and a list of the attributes that we want to copy from that alarm, and in the top box a list of all the alarms that are selected that we are going to copy the attributes to. Now let's talk about the management of change process. To my mind and in my experience, the controlled repository of alarm information and attributes should be the master alarm database. Now this should be a controlled document or database with all the management controls that you would expect for such an entity. So changes will be made first in the master alarm database and then migrated to the DCS or SCADA under controlled conditions. However, in real life, that may not be the case. For various reasons, changes may be made online in logic controllers or in the alarm server and then exported back to the master alarm database, making the online system the controlled repository of alarm configuration. And often that copy back to the master alarm database does not take place. Whichever process you use, it should be properly controlled, and the changes should be recorded in the master alarm database. When we start rationalizing alarms, the status in SIL alarm is set to TBD or to be decided. And as the rationalization proceeds, we can set the status to reflect where we are in the rationalization process and record what we are doing as the rationalization proceeds. Now, the last phase in the alarm management life cycle is an audit, and it's often carried out separately from the other phases of rationalization. There are two aspects or purposes to this audit. One is to compare the performance of the system to see if improvements can be made, and the other is to check that the alarm configuration is consistent within the system. During this phase, periodic reviews are conducted of the alarm management process that are used on the plant. The operation and performance of the system is compared against the principles and benchmarks documented originally in the alarm philosophy. The goal is to maintain the integrity of the alarm system and to identify areas of improvement. The alarm philosophy document is modified to reflect any changes resulting from that audit process. Well, the first step in an audit is to check that our master alarm database reflects what's in our various input documents, like our alarm philosophy document, the various HAZOPs and LOPAs that we've used. And once we've confirmed that the master alarm database is correct and matches those documents, we can then check the rest of the system against our master alarm database, and we can review those changes and make a decision as to whether they're correct or not. So here we are at the review page for SIL alarm, and we can review those differences, and this page enables you to take different actions depending on what your decision is. You can implement those decisions en masse, or you can do them individually. So here is where you can decide that differences are valid and you've been made by an authorized person, in which case you can accept change and make them permanent in the master alarm database. You can decide that they warrant further investigation, or you can reject the change, which will leave the system as is and produce an audit file for further consideration. You can reject the changes in a way that will enforce what is currently in the master alarm database and overwrite the changes in the SCADA system. And here's a close-up so you can see in more detail the ability to accept or reject these changes, and you can record the details of who made these decisions or who made the changes, your decision to accept or reject it, and why. So that's pretty much the end of this session. So in summary, the master alarm database is a list that's formed from several input documents, and then each alarm in the master alarm database is rationalized to check that it's a genuine alarm and it's configured appropriately. This master alarm database can then be used to configure the DCS or the SCADA. It can produce alarm response procedures, document the design of system alarms, and advanced alarming techniques that were used. All of this has been recorded in the Master Alarm Database, the authorized list of rationalized alarms and associated attributes. We have used the best practices and considerations in creating alarm response procedures. We can use the information that's stored in the Master Alarm Database and connect it straight into our control system. We can use filtering in the Cell Alarm tool to bulk engineer and rationalize alarms. We can integrate that information into our management of change process, and we can audit and enforce changes that we've made or have been made to the Master Alarm Database. So that's it. Thank you for attending this short session on Master Alarm Databases. If there's any further information or any questions that you would like answered, please feel free to contact me at the email at the bottom of the page. Thank you very much.